Record. Okay. Going over homework from last time. Limit as n goes to infinity, a to n plus 1. Absolute value of a to the n plus 1. In fact, I'm going to stop doing so much extra work now. Times the reciprocal of a sub n is going to be n cubed. Did you guys notice that the APU is supposed to have their app for testing out today? Did anyone check for that? No, probably not. I didn't see it yet. Yeah, they were supposed to have an app available for practice. So, okay, I can't cancel these out because they're connected by a plus 1. I'm going to expand this factorial part. This is like n plus 1 times n minus 1 dot 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 down to 1. And this factorial expands to n times n minus 1 dot 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 down to 1. When you get good at this, you realize these all cancel except for one extra n plus 1 on the top. So this work is going to reduce down to, and the absolute values don't matter because nothing's negative here. So I have an n plus 1 times n cubed all over n plus 1 cubed. Now, the idea is we have polynomials right here, and what are the degrees of the top and bottom? So if I distribute this n cubed in, I could rewrite this as, let's say it's going to be n to the 4th plus n to the cubed. Now, do you have to expand this? Okay, you could expand this if you wanted to. You'd get n cubed plus 3n squared plus 3n plus 1. How do I know this? Have you ever heard of, like, I think it's like Pascal's triangle? Have you ever done this? Where, like, you're just adding up like this? I just remember that pattern when you cube things like that. It's going to follow these coefficient rules. Anyways, you don't, or you could just FOIL it out a bunch, right? When we're dealing with this, we're looking at the highest degree. We have a 4th degree, we have a 3rd degree. Since the top's a higher degree, this is going to go to infinity, so we're going to say diverge right here. It's going, if it's greater than 1, it diverges, all right? Now, let's say you didn't want to multiply this out because that's way too much work. The question I ask is, what is the degree of the top and bottom? Okay, this was easy to figure out. The degree is 4 because, FOIL, you just distribute that in. On the bottom, if we have, think about this, I'm just cubing the n part. N times n times n is going to be n cubed because of that cubed. Hopefully you can realize without foiling this out that higher degree on the top. All right? Shortcuts for that, whatever you want to do. Okay, moving on to the next one. I got to make room, sorry. Let's do number 4 right here. So I'm going to even shortcut some of the work. I'm not even going to write a to the n plus 1. Limit as n goes to infinity. I'm going to write out this much work at least. So it's going to be negative 3 to the n plus 1 over n plus 1 factorial times the reciprocal of this, so n factorial over negative 3 to the n. All right, so expanding, okay, I can cancel out. I have an extra negative 3 up here, so I'm actually going to cancel this out with this, but just leave another negative 3. This is like one extra. Now these factorial parts, this is like n plus 1 times n minus 1 all the way down to 1. And this is like n down to 1, right? So we can actually cancel out everything except for like just an n plus 1 left on the bottom. So what you should have is negative 3 on top, just a negative 3, on the bottom an n plus 1. And that's all that's left after I reduce. The negative actually doesn't matter with the absolute value, so I'm going to just change it to 3 over n plus 1. N goes to infinity. And this would just be 3 over infinity, which is going to be 0. 0 is less than 1, so we're going to say converge by the ratio test. All right? Now let's do the last one. I'll do number 5. I'm going to do number 5 way over here. So this one is probably the weirdest. Okay, what's weird is this is like the n's connected to this too. So when you do the a sub n plus 1, I'm going to do that work. A sub n plus 1. It's not 2n plus 1. It's like 2n plus 1 factorial. Like the 1 is being added to that n over n plus 1 times 3 to the n plus 1. So really, if I were to do this, I want to distribute this too because it's going to make more sense. So it's like 2n plus 2 factorial. It's not 2n plus 1, it'll be 2n plus 2 because the n's connected here. Over n plus 1 times 3 to the n plus 1 times the reciprocal of this, n 3 to the n over 2 to the n factorial. All right? And when you're doing this problem, multiplying this out, what cancels? I'm left with 1, 3 here. The n plus 1, the n can't. If you're distributing this out, oh, I should have given myself more room. I can do that. So I'm gonna distribute these out. This is like 2n plus 2, 2n plus 1, 2n dot 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 down to 1, and this is like 2n dot 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 down to 1, right? So what cancels out here? This whole thing, but I'm left with just these two terms. So I have on the top and this, and don't forget that n. So I have a 2n plus 2, 2n plus 1 times n all over n plus 1 from that, and then times 3. All right, now it looks like a mess, and I could FOIL these out, but here's the thing. What's the degree on the top and bottom? We're polynomials here. On the bottom, it's just an n. So I'm going to say this is a degree of 1. On the top, I have an n times n times n. It's technically like 4n cubed. So I have a third degree on top. The top's higher degree. So this limit's going to go to infinity. And therefore, this is going to diverge as well. So it's important. This was important to realize plus 2. Actually, if you actually mess that up, you still probably got the problem right, though, because it's such a higher degree. But that's the work to do that. All right. I'm going to keep going on. So I'm not seeing questions stopping me. So let's go to 19. And I'm recording, too. So, all right. Actually, do I have my sound going? That'd be really... Okay, it is good. 19. Okay, so this is an AP style problem, especially this first part, part A. Actually, this whole thing is. So, okay, the function has derivatives of all orders of real numbers x, given f of 3, f primes, double, trippy prime. What's the third degree Taylor polynomial? So if I'm doing step A, the first thing I'm doing is I'm just writing out a third degree Taylor polynomial formula, right? I would always do this even if you're like, I know this by heart, I don't need to do this. This is good practice. You want this for the AP test. So I'm writing f, and I'm centered at 3. So f of 3 plus f prime of 3 times x minus 3 plus f double prime of 3 x minus 3 squared over 2 factorial plus f triple prime of 3 x minus 3 cubed over 3 factorial. I would write that out first. Sometimes you just get points on the AP test for having that too. Now we just got to plug in for each of the f of 3s. So if I'm plugging in, I got f of 3. This will be negative 2 plus 4 x minus 3 plus 2 x minus 3 squared over 2 factorial and plus negative 9. You could switch it to minus 9 if you want to. I don't care. X minus 3 cubed over 3 factorial. I'm not going to simplify anything. I'm just going to leave it like that. Sure, you could simplify, your call, but nah, I'm not going to bother. So that's step 9, A. That's stuff that could be on the AP test. Now, part D, this is where it tripped me out a little bit and the way I did this. And I'm going to show you how you might have done this because I haven't told you some of the like substitutions here. But it's good to practice this. So fourth degree Taylor polynomial for g of x, which is based off of f of x. So you think, oh, okay, well, let's write out a fourth degree Taylor polynomial. So the first thing you might do if I'm doing part D right here is I'm going to write out a fourth degree. So t to the fourth of x is f of, I'm not going to say f of 0, I'm going to say g of 0. Plus g prime of 0 times x plus g double prime of 0 times x squared over 2 factorial plus g, I keep saying f, g triple prime of 0 x cubed over 3 factorial plus g to the 4th prime of 0x to the 4th over 4 factorial. Write that out first, all right? Now, I got to figure out g of 0 and g primes. So I'm actually going to make a table for this, all right? And this is where it got crazy. And part of it is because it goes to the 4th degree. I was doing this yesterday, but this is good practice. So let's say we have to do g of x first. So we know what g of x is going to be f of x squared plus 3, because that's given. So that means g of 0 is going to be f of 0 squared plus 3, so f of 3, which is just negative 2, because we're given this up here, okay? All right, that's simple. Okay, now we got to find g prime of x. So let's go g prime. Oh, I'm going to run out of room. So I know this is going to... I'm going to do this over here. You'll see why later. G prime of x. This is like a good chain rule practice. It's going to be f prime of x squared plus 3. This is actually good practice. Times 2x, okay. So then g prime of 0 would be f prime of 3 times 2 times 0, which is just going to be 0. Whenever I'm multiplying by 0, it's going to go away to 0. Okay, so that's 0. Easy, right? Okay, let's get a little bit more complicated. G double prime of x. You got to product rule this thing, right? So I'm going to go my product rule. I forgot how you guys do it. What's your order? I do f prime g plus fg prime. Is that how you do it in order? I'm going to follow this order unless you guys want something different. You guys probably learn differently, but that's the order I'm going to do things in. So I'm going to say it's f double prime of x squared plus 3 times 2x times this 2x plus f prime of x squared plus 3 times the derivative here, 2. Okay, that's the product rule. Cool. So now if I plugged in 0, wait, no, let's keep it red. So g double prime of 0. It's this first term, since we're multiplying it by an x here, this is just going to go to 0. So I'm going to go 0. And then this term's going to be f prime of 3 times a 2, which is going to be 4 times 2, or 8. All right. Hey, a little bit of work here, but let's keep going through this. This is good practice. G triple prime of x. All right. So, okay, I'm going to rewrite this a little bit right here. So that's 2x times 2x. It's going to save me some time here. I'm going to change this to 4x squared. All right, I got to product rule this part. F triple prime of whatever, I'm giving up, times 2x times 4x squared plus f double prime of whatever times 8x. And then just the derivative of this is going to be f double prime of x squared plus 3 times 2 times 2x. So it'll be times 4x. All right. If you plugged in 0, what would end up happening? This is going to go to 0. This is going to go to 0. And this is going to go to 0. We're at 0. All the terms 0 out. Now, the last thing is doing it to the 4th derivative. You look at this, you're like, what? How many product rules do I have to do? I'm going to rewrite this as 8x cubed. I got to product rule this. So to save us time, and you product rule this, we're going to have the same problems where this is just all going to be zeroed out. There's going to be times some x's. When you product rule this one, okay, so I'm going to product rule this one. It's going to be f triple prime of whatever times 2x times 8x, 16x squared, And then it'll be plus f double prime of whatever times 8. And then plus this one right here, which is going to be f triple prime. This is product ruled again. Of whatever times 2x. It's going to be 8x squared or something like that. Times f double prime of whatever times derivative of that is 4. All right, so if you did all this, this term, that goes to 0. This term is going to be a 0 term. This term is going to be, so g of 4 of 0 is going to be f double prime of 3 times 8. This would go to 0, and then it'll be plus this last term, f double prime of 3 times 4. Double prime of 3 is 2. So we're at 16 plus 8, which is 24. Wow, that was a lot of work. So you do all this, and you're plugging in here. Your final answer would be that, and that. So it'd be negative 2 plus, since this coefficient is 0, this term just goes away. And then this term's coefficient is 8, so it's going to be 8x squared over 2 factorial. And then this term's going to be 0. And then this term's going to be a 24. So plus 24 x to the 4th over 4 factorial. So your answer is really gross, but it's this. If you did it the way that I taught you, okay, great. You have a long product rule. I think by the time I got to this part, this was ridiculous. It should have stopped here. There's another way to solve that problem. I went over last time, but I don't really want to do it right now because long day, and we're going to be covering this later. And I'll come back to that same exact problem. Last question was answering how to find a local min or max. If you got to this point, you would have to like derive it and then see if it's a critical number. I think I'm going to skip that question unless you want to see that, because I bet a lot of people didn't get this unless I have a request. We'll come back to that problem, I think, on a different version. So there was that homework. Let's get into today's stuff. All right, interval of convergence. This is day 1 of interval of convergence. We'll definitely come back to this. We'll save the warm-ups for another day. So this interval of convergence is kind of an extension of the ratio test. So last time we did tests that looked like these, and I just did the homework problems right there. Very similar to these. Ratio test was good when you have factorials, an exponential series, and there's always ends in this, and we ask, does it converge or diverge or whatever? And we say, one thing with ratio test, it converges when the limit, as you go to infinity, of a to the n plus 1 over a to the n is less than 1. We can say it converges by the ratio test, all right? And this is a key understanding here. We want to know when it converges. And this is when ends is like our counting number. It's an integer starting at like 0 or 1 and going up, right? Now I'm going to put an x in there too. How do you have 2 letters in here? Like 1 letter's bad enough. So the idea of putting the x in, we're adding a second variable. And when I say interval of convergence, I say, hey, what if I had this thing? Tell me, I don't want to know if it converges or diverges. I want to know for which values of x does it converge or diverge, right? So if that's what this interval of convergence is, like which values of x will this converge? For which values? Not does it converge or not, it's when does it converge? So we're actually going to be using the ratio test. So it converges depending on the x. We're going to figure this out with the ratio test and say, okay, figure out which x values need to in what range, which is the range that the x values will converge. And it's basically through the ratio test. Now, there's another key part to this that, ratio test, we know it converges when it's less than 1, but what about when it equals 1? That's an IDK, right? I don't know with ratio test. We actually have to check the endpoints using different tests. So, hey, when it's like, hey, and that's not bad enough that we have to figure out an interval, now we got to check these things. So it could be a little bit more work here. But watch what this looks like. Like, You know, if I ask, here's a for example right here. No, I don't have a good for example. We're going to be doing these examples, right? Are we doing these exact ones? Yeah. Okay. So let's take one. What if I asked you this one right here? And I say, this is x to the n power. When does this converge? What if I just had that? And I'd ask you, well, for which x values does this converge? Okay, let's use the ratio test right here. So I'm going to go a to the n plus 1 would be x to the n plus 1, right? So my ratio test would be the limit as n goes to infinity of x to the n plus 1 times the reciprocal of this. So I'm going to say 1 over, I can put an over, x to the n, when that is less than 1. Who was the one? I forgot who were the people that weren't here today. All right. So, let's say I did this. What do I cancel out? I'm going to cancel out this, going to cancel out this with an x, right? I'd say, oh, I'm left with absolute value of x is less than 1. And you're like, wait, n goes to infinity. Where are the n's? Just goes away. I mean, n goes to infinity. In this case, it doesn't affect it at all. So we're just going to say absolute value of x is less than 1. This is when it converges by ratio test, when absolute value of x is less than 1. Now, another way of saying this is when x is less than 1 and when it's greater than negative 1. Right there is when it converges. That's a way to rewrite this. Now, you might say, okay, there, my interval of convergence is right there. It's -1 to 1. This might look familiar to you. Remember the geometric series test? That always converged when r was between 1 and -1. This is a geometric series. I solved it with the ratio test and showed you the interval of convergence, but it's exactly the same thing as the geometric series test. So I showed you this just to give you an idea of what this might look like. In this case, there are no n's. This is like the simplest problem I can give you. Let's go up a step. All right. Let's say if I did something a little bit smaller, I'm leaving that up there in case people want it. Okay, what if I did this? So I could do the ratio test for this one too. And it's going to follow, it's going to be x minus 2 to the nth power, n plus 1, times the reciprocal of this guy, it's minus 2 to the nth. If I followed these same rules here, this would all cancel. I'd be left with 1 extra n plus 2 in the top. So I'd have an absolute value of x minus 2 is less than 1. Limit as n goes to infinity. There are no n's, so I can just say the absolute value of x minus 2 is less than 1. Okay, so when I want to figure out this interval, I want to like isolate the x. So one thing you want to do here, and I'm going to show you isolate the x. We want to really get it down. I have to figure out this interval right here, right? So I'm almost there. Well, let's rewrite this without absolute values. So whatever this number is, you put it between the positive and negative versions of this number. And now to isolate the x, going back to your Algebra 1 and 2 days, I'm going to add 2 to both sides. But it's not just both sides, it's all the sides. So that cancels out. My interval becomes positive 1 is less than x, which is less than 3. So my interval and convergence in this case would be between 1 and 3. And this kind of makes sense. This -2 shift means I shifted 2 positive from this. This is like a +2 shift from this interval to this one, if you want to think about it that way. So I show you these as like basic intervals of convergence. They were just geometric. They're both geometric series too. All right. Now I want to kick this up a little bit. A lot of it. Okay, let's say it's a little bit more complicated, right? Not a lot of it. Let's say a little bit here. A little bit more complicated, right? What intervals? I didn't need the ratio test in those past ones too. If you could recognize it was a geometric series, you could have just done it as a geometric series. But let's applying this with the ratio test right here. All right, interval of convergence. And I also didn't check the endpoints over there. It was geometric, I didn't have to, but I'll do it for this case. So let's do this problem. Give me a little bit more room. All right, so I'm going to write my limit out. Don't be scared, you can do this. A sub n plus 1, this would make this 2 to the n plus 1, x to the n plus 1, over n plus 1, I'll put that in parentheses, times the reciprocal of that thing. Less than 1, right? So all right. So I want to play the cancel game. Hopefully you can see this cancels with just an extra 2. This cancels another x here. This n and this n plus 1, they can't cancel. Otherwise you kill kittens. So I'm left with 2 times x times n on top and n plus 1 on bottom. Still with this limit. Now, this is a good problem to show how the limits with n, there was no n's last time, but there's n's this time. How does this come into play? I want you to when you do this part, you have to ignore treat this x as just a coefficient. We're really going to be looking at the n's part right here and here. I'd almost think of this I'm going to think of it as just this part. It's almost like rewriting this as 2x on the outside, because this is just coefficients. We can do that. Times the limit. Well, and because it's a positive 2s too. Almost think about it like this. It's actually just like n over n plus 1. And what would be this limit right here? They both have a degree of 1 on top and bottom. So it means the limit for these two things is just the coefficients, 1 over 1. So this is just going to be 1 times 2x. We're still absolute value, right? So another way of saying this is you got to look at this part here and think, what's that limit going to be? Or treat this like the x. Don't treat the x as a variable at that point. Times 1. Ultimately, these are going to cancel out, so I'm down to absolute value of 2x is less than 1. That's what you simplify it down to after you do that limit stuff. Limit is gone. Let's get rid of those absolute value signs. And then isolating the x, we divide by 2. So I can say my x is between 1/2 and negative 1/2. So that's my interval of convergence. However, You need to check the endpoints. And when I say check the endpoints, I mean at the endpoints are the left and right sides right here, 1/2 and -1/2. I need to check when you plug in these numbers to this, will it converge or diverge? Because this is the ratio test is inconclusive at those endpoints. So let's plug in -1/2. You plug in that -1/2. I'm going to get the interval of 2 to the n times -1/2 to the n over n. Okay, that's 2 to the n, -1/2 to the n. If you remember your properties of exponents, that's like 2 times -1/2 to the n over n, which is going to be -1 to the n over n. Now, okay, I'll ask in chat. This thing, does it converge or diverge, and by which test?